Welcome to the fourth film in our Structural Members series. In the last film we looked at external forces and how they are transferred to various types of bearing. But how do these external forces act within structural members? Internal forces transfer external forces through a structure and into the ground. This is the digital structural model for the reinforced concrete structure of the Priory Church in Leipzig. The black lines are force lines. Where they run close together, they indicate areas of increased stress within the concrete structure caused largely by load concentrations, openings, and bearing conditions. When pressure is exerted on a component from the outside, as shown at the base of the building here, the external compression forces create compression forces inside of the component. The same is true where a force acting along the length of a component is a tension force. If a component is subject to an elongation force from outside, as is clearly the case here, there is also a tension force acting within the component, in this case in the tie rods supporting the lateral elements. In the previous two examples, we looked at forces exerted lengthwise within a component. These are referred to as axial forces. When an external force acts at right angles to the component, we call it a perpendicular force. A perpendicular force is a shear force and acts like a pair of scissors cutting through paper. Shear forces can cause components to shear off and should be avoided, as in the case of this canopy structure in Uruguay. Externally applied torque produces a bending moment inside of a component. The ends of the beams in the museum structure would sag downwards had the appropriate preventive measures not been taken. When a component bends, one side is being compressed while the other is being stretched or elongated. Bending therefore generates compression and tension forces within the component. These forces are greatest at the edges. The key point here is that whenever a component is subject to bending load, both compression and tension forces are acting inside of it. Summary: compression and tension forces act in the same way within a structural member as they do outside of it. Axial forces act parallel to the direction of the component, while transverse forces act at right angles to it as shearing forces. Bending produces compression and tension forces at opposing edges of the structural member. We recommend that you take a look at the fifth film in our Structural Members series, in which we discuss some of the structural members that can be found in simple buildings.